Hello everyone, it's Kevin from KJD Electronics, and welcome back to another one-stop programming video for absolute beginners on Python. In the last video, we covered booleans and conditionals, and in this video, we're going to go over an introduction to exception handling and loops. But before we get into all that good stuff, I want to take a minute to go over the challenge I posed at the end of the last video. Now, I've made the code changes here, but I've also posted the change in the forum with a link in the description, so you can go ahead and follow along there and copy it to your local machine. So the first thing I changed was I added a comment to our main function that basically defines what our program does, so anyone looking at this file will be able to quickly figure out that this is a calculator program that takes input from the user and does operations with two numbers. I also added a comment to just define our input block here where we're getting input from the user, and then I changed our prompt for the operation to ask for a number instead of, add, subtract, multiply, or divide, and I provided the numbers that I want to get in the prompt itself. I then added a comment to define our if block here, saying that this if block is responsible for determining the operation that we want to run. And I changed our if statements from using a string to compare the operation to comparing directly to an integer, because we are parsing the input that we get up here into an int. I also added a little print statement just so we can see what operation we're doing in case we forgot. Alright, so that's all the code changes for the challenge that I made. So let's go ahead and test this and make sure it works. So we ask, what is number 1? We'll give it 1. What is number 2? We'll give it 5. And let's say we want to multiply, so we'll enter 3. We print out multiplying, and we get the expected result of 5. Great. Our program works. Now, like I said, I'm going to proceed from here with this version of the program. So if you haven't done it already, go ahead and copy this down or run over the forum and get the code that I pasted there. So let's run this again. And now I'm going to introduce what happens when we see that red error text. What an exception is. So I'm going to enter number 1, and I'm going to enter number 2 as 2. And let's say I forget that we're doing a number here, and I say add instead of entering 1. Now I'm going to get an exception for value error, invalid literal for int with base 10, the string add. Now that's basically saying it can't parse the string add into an integer, so we get an exception. Now, we don't really want to just blow up when our user is using the application and makes a simple mistake like typing the word add. We want to give them a nice message saying, you entered invalid input, you need to try again. So we need to handle this error, this exception, and print out an error message to the user and then exit gracefully. You'll notice that the exit code down here is 1, and that basically means it's an error. When we run it and we don't have an error, you'll notice the exit code is 0. Now that can be used in a variety of different ways, but primarily it's used to report, if the operation was completed successfully or not, if this was being called by another application, let's say. I'm going to now introduce the try except block in Python. Now, what the try except block does is it runs a block of code. So for us, that will be our input block here. And if it gets an exception, it runs a different set of code. And if it doesn't get an exception, it ignores the set of code to run if there were an exception. The way that works is I'm going to enter a new line. I'm going to hit and type try, colon. Then I'm going to indent everything that I want to be part of that try block. So I'll hit tab. And then we scoot back out to the main indentation level. And I type except, colon. And then we go down to another indentation level, and I'll print invalid input. All right. I should be able to run this. And if I enter add, I should get this nice invalid input message. So I'll do 1, I'll type add. Well, we still got an error, but we did print our invalid input. But the error we got now is no unbound local error, local variable operation referred before, or referenced before assignment. Now that's meaning is we're getting down to this line on line 31, and we're trying to evaluate whether the operation variable is equal to some value. But it can't do that because we've never set the operation variable. The operation variable was supposed to be set up here, but when we tried to set it, there was an exception, and we printed invalid input. Now, what we really want to do is exit the program in our except block. And if you recall, main is just a function, and it doesn't return a value, it just ends down here. But what we can do is we can artificially force main to exit by typing return with no value. So in our except block, we can just say return, and I'll put a comment, exit the program because of an error. And in our print statement, I'll say invalid input the program will now exit. So now if I try this again, what is number 1? 1. What is number 2? 2. And I'll type add. I'll say invalid input, the program will now exit, and then we don't see an error message printed to the console, and we get our graceful exit code of 0. Now if we look back at our code, we'll see that IntelliJ is adding this little squiggle after our return statement. So if we scroll over that, we'll see that it says PEP8 at least 2 spaces before inline comment. Now PEP8 is basically the style guidelines for Python, saying how your code should look when it's written. So it's basically saying that the PEP8 guideline says you should have 2 spaces before an inline comment, which this is because it's a line of code and then a comment in the same line. So if we just add another space, that squiggle will go away because we are now compliant with the PEP8 guideline. Now if you notice, we also have these other squiggles down here that say remove redundant parentheses. Now if you recall in the last video, I said that we needed the parentheses for the if statement, and that was just out of a force of habit of mine because in most other languages you do need the parentheses, so I tend to use them anyway, even though they're not strictly required. And I'm going to keep them there just for consistency's sake. Alright, so now we have our try except block that prevents the application from crashing if the user enters an invalid input for either num1, num2, or the operation. Now I didn't test explicitly num1 or num2, but you can go ahead and try that on your own. So what if we didn't want the application to exit? What if we wanted to give the user as many shots as they needed to get the input correct before the application exited? Well, to do that, we need to loop. We need to run this code over and over again until we know that we completed this line of code without an error. So to do that, let's go ahead and create a variable up here on the first line of our main function called valid input. Now let's initialize this variable with the assignment operator to false. What I'm saying here is I want to create a variable called valid input. I want to set it to false because when the program first starts, we have not yet seen valid input. Now down here in our try except block, after we get the operation, I want to set our valid input variable to true. Now what this is saying is if we reach this line of code, it means that no exceptions occurred up here, which means that we must have valid input. So if we entered an invalid num1, it would throw an exception and would print our invalid input. Or same with num2 and operation. If any of these throw an exception, we will never reach this valid input line for setting it to true. So now that we keep track of whether or not our input is valid, we can use this in a conditional to validate our input. So I'm going to introduce the while loop. So what we want to do is we want to loop until valid input is true. So to do that, we type while valid input and then a colon. And then we want to indent everything in our try except block into this while loop. So this while loop is just like a Boolean evaluation. I could say valid input equal true. This is just like a Boolean expression that we have in our if statements. Now IntelliJ is saying expression can be simplified, which it can be, because that was a redundant statement, saying if evaluating something is true, it is not necessary because this is a Boolean expression. Now, whenever valid input is true, this will run. So we set valid input to false up here. So if we ran this now, what would happen? Well, we immediately get an exception because operation isn't defined because we never prompted the user for the numbers or input. So what we really want is while not valid input, get input. So we can move our comment down here so it can read a little bit more simply. So now we can almost read this like English. While there isn't valid input, get user input. Try to get num1, num2, an operation, and if you're successful, set valid input to true. Otherwise, there's an exception, print invalid input, and now we'll change this to try again. And we'll get rid of our return statement because we no longer want the program to exit. So this is where Python can get tricky because we now have a couple different levels of indentation here. We have our main leftmost indentation where we're defining our functions, and we're calling our main function down here on line 50. Then we have the first level of indentation, which is the first level of indentation in the main function. Then we have a while loop that has an indentation associated with it, and everything in this indentation level is part of the while loop. And then to come back out of the while loop, we just simply return to that original indentation loop, or indentation level, for our main function. Then we have another indentation level for our try except level that defines what's inside those blocks. So you can kind of see that along the same idea, you have whatever is on an indentation level will be executed in a block. So for example, only one of these if statements will execute at a time, and it will execute everything in the block up until the next if statement. Same thing with the try. It's going to do everything here until it has an exception, at which point it's going to stop and do everything in the except indentation level. So let's go ahead and run this and check to make sure it works. So I'm just going to type x for num1, invalid input, try again. I'll try 1, and v, invalid input, try again. 1, 2, let's subtract 2. Subtracting, we get -1. Perfect. So our application ran exactly how we wanted it to, where it looped until we got a valid input. It handled the exception gracefully when we didn't give a valid input, and told us to try again. Now, we just covered a lot of really powerful tools that allow us to, write code that is more reusable and cleaner because we're handling exceptions instead of allowing exceptions to be thrown to the user. Now, to make this program even more useful, I want to challenge you guys to use the while loop, another while loop, to continue running the application until the user says they're done and don't want to do any more calculations. So the program should start, it should ask for number 1 and number 2, and then it should, after it's done the calculation for whatever operation was specified, it should ask if the user wants to do another operation or if the user wants to exit. If the user wants to exit, the program should exit and close and finish with exit code 0. Otherwise, it should prompt the user for another num1 and num2 in operation, using the same code we have here, and it should handle the exception the same way. You guys know you have all the tools to be able to do that at this point. Now, I also want to pose a poll that should be popping up on the YouTube screen right now, and that is, do you guys find these challenges useful, and do you want me to keep giving them? Alright, so that's all for this video. Please remember to like, comment, subscribe. I'm Kevin from KJD Electronics, and I'll see you in the next video where we cover more on exceptions and writing clean code.